Yeah, so good afternoon, ladies and gentlemen. It's already afternoon. My talk will be a whirlwind report about the Metafora project, about different facets that are related to learning analytics, about the architecture, the data we collected, and the analytic methods. But also in the context of this conference and, for example, Abelardo's very inspiring invited talk, it could also have the subtitle, The Tales or even the Confessions of a Tooler, about an interdisciplinary approach to reach the middle space. Confessions is maybe appropriate because I'm also from a Catholic university, so it's my sister university here, and maybe it's time to confess now. So what we did in the project is to co-design together with our pedagogical partners and the teachers a system to support collaborative learning. You see that here on the very left side, the brain. Then the toolers tried to build a system according to the pedagogical principles and the desires of the teachers. And then we tried to analyze, reflect, and feed that back in an iterative design, but we also developed analytic components that we want to expose to the users, namely the students and the teachers of the system, and to see how these analytic features can support their learning. And this is currently still an ongoing process, so this will be at the very end of the talk. The outline is first to give a short introduction to the Metafora project and its pedagogical grounding, then the introduction into the architecture for analytics, which I hope that I can connect to some statements made in the panel this morning, and one example case of an analytic agent for planning behavior that was developed in my team. And finally, some report about data collected in the practical use in the classroom and the analytic methods we right now are currently conducting to see if the analysis and especially the feedback produced will change the learning and hopefully benefit the learning. So the pedagogical background of Metafora is self-regulated and collaborative learning with diverse heterogeneous learning tools, mainly in the domains of math and science. The main target group is secondary school in small groups, so we are currently not yet caring about community effects, but we would be interested in that. And the learning scenarios are relatively complex, so they are called challenges, and they are extensive lessons consisting of several sessions, approximately 20 hours. So it's not so easy to get teachers who are willing to do such a long stretched activity. We heard that also in earlier talks that this might be a problem, but we found teachers willing to do that in the project preparation. One of the key competences in our approach, and we want to test, is planning as some facet for learning to learn together. We call L2L2 as an acronym for that, for this pedagogical approach. And the system shall not only provide the means to act and learn, but it should also provide intelligent analysis on how they are performing and how they are interacting. So first of all, Metafora could be perceived as a toolbox because it's a web-based tool and it has the relatively conventional usage of web launchable tools inside. So what you see here is a toolbox on the left bar and some specific learning tools that are in the main space. Here is a physics microworld, which is a constructionist approach where students can manipulate their own model and vary variables in a scientific approach. These tools can interoperate with each other. So even though it's a toolbox, there is some semantic level of, for example, exposing part of this model into a discussion environment where it can be discussed and explored again by the peer learners, so they can click on the link in the discussion environment and come back directly to this model. So we have a quite strong semantic interoperability, even though it's loosely coupled technically. The planning tool is the main tool, at least from the perception of my group, because we developed that. It allows the learners to self-organize their activities using visual elements. These are categorized. For example, there are shapes or cards that represent activities, attitudes for discussions. It could be critical or open or reflective, specific roles in the task organization, and then connectors. Learners can also document the progress and status in their plan. So if they started activities, if they finalized activities, like in a project plan. This is very abstract, so I show you a picture. Here are some cards of different type. So the main activities are the large green ones, and you see that some of the cards are colored yellow, which means that they started using it. So if you click on the card, and you can seamlessly go into the tool and back, and this top-level card build model, the students declared to be finalized. So they said, we are done with that. And this documents both for the students, but also for a teacher inspecting this work. The technological backbone in Metafora is we use diverse web technologies. I think I will go quickly here. Because it's a collaborative system, we need to have some server push functionality, because the actions taken by one student have to be broadcasted to the other group's members. And we used graphical toolkits, the Google Web Toolkit, XMPP as a communication infrastructure. Some people might know it under the name Jabber. That's a chat client of relatively wide prominence, and some uniform XML format. Maybe it's the 16th of these standards. We do not call it a standard, but for us it's kind of a unified format for the project. The extension of the system with AI components was a major issue, because we want to support students and teachers properly by giving them analytic feedback, because we had a host of different teams that are interested in AI programming and this feedback generation. We wanted to have a flexible architecture, and also had the need to add additional analysis components even at runtime. So we wanted to have a technically flexible system. We also wanted to be heterogeneous with respect to implementation languages, because some of the partners have been in the traditional way of AI programming with Prolog and Lisp or Jazz, and some of them use very different techniques or even have legacy components doing the analysis. And so we want to have their flexibility. On the other hand, we want to have analysis results across several tools, because they are highly interesting. For example, do the plans in the planning tool match with the activities in the physics microworld? Is there an interrelation that is coherent? Therefore, we need some understandable format, at least on abstraction level, that allows this cross-tool analysis. Here's an overview of the analytic architecture. One of the main components are these channels. These are XMPP channels, and you could think of that as a modified blackboard architecture. So the analysis components can subscribe to these channels and can then produce write their products of analysis to the channels. So the agents or the components do not interact directly, and they can make use of the other components' results. In our special case, the red one is the Plato analysis agent, which digests user actions coming from the planning tool and writes results of analytic nature to the analysis channel. It could also take up information from the analysis channel if that would be interesting for the interpretation of the Plato agent. Here's a short list of the Plato indicators. I will go quickly here. They are mainly oriented towards the teacher's needs, grounding in literature, and we also try to take up some analytic literature there, for example, the uptake analysis of DEN, in indicators for collaboration where students connect to resources produced by other students. Here's a very short example. I will go here very quickly. You see a plan that is produced. It first has a split, then has a join. So the system would analyze here that a split happened, so some divergent planning behavior. Number 5 is the confluent learning behavior, and number 4 is that there is some semantically integer model at this moment, because it's kind of a solid workflow structure. I think I will skip that to allow some more questions. We have collected now data from practical usage, so we used it in school classrooms, have a data set which is not big data in the sense, it's also smaller than the role repository, but we hope that we can apply there a lot of AI techniques now to create the indicators we desire to have for the teachers and the learners. Because we don't want to impose now the feedback untested to the students, we thought we will do methodologically first some kind of observation procedure. So we have the log file stored and we can replay it into the system. Then an expert would see, as he would have done these activities by the user, so he's like on TV, and he can then, because he gets the feedback of the analysis components, he can then see if it's useful, indifferent, or not useful. And so we get some coding on the usefulness of these indicators. That's our plan. What we want to do with these analytics results, and this connects nicely to Alyssa's talk, that we want to have small tools informing students and teachers. So here we have an embedded tool, we call it the reflection tool. It can and should be probably folded away for the most time, but the teacher can inspire the students to fold it down and do some reflection about it. It is very much oriented to let's say sports live feeds and tickers. You might know that. I have here one from a recent soccer game. So you have a timeline, you have the goals, you have red cards, yellow cards, you have substitutions, and that's almost the last. And we have similarly here log in, log out. We have specific events, and we have a connection from a Gantt-like connection from the different cards. So for example, the length of this bar represents how long this activity was open and undertaken. And yeah, so I summarize, Metafora is a project for complex collaborative learning processes. We try to address different needs for the analysis, especially heterogeneous expertise at the different partners and flexibility involved in that, in the architecture. A showcase agent to demonstrate how we want and how we do use AI techniques. This is a JAS-based agent to create feedback on several different levels. and the data set available. Our current activities are to conduct an eye tracking study for the effects of feedback messages. So this is mainly the HDI aspect. If the users really see and perceive it, and to apply our relatively general approach of the Plato agent to a new agent called Conan that replicates the contingency analysis and uptake analysis of DAN. And we have there currently 4 of these 5 dimensions and are eager to test it also to our data set. And that's it. And I hope I have a little bit time for your questions.
For the, with both of your talks, I'm wondering to what extent are you offering a solution, an approach, a platform for doing learning analytics, and if you are, is the solution at the level of the implementation you actually have or more at the approach, the architecture level? So what's others' take home for this?
Okay, I would say our approach was mainly demand-driven by the pedagogical partners and the teachers. So they had an interest in being aware of what is going on. This mainly influenced the definition of our indicators for analysis. And the architecture, I would say we tried to resolve the different forces also in the technical team. We got relatively good experience both with legacy systems that have been pre-existing before with analytic capabilities, so some of the tools already had some, and also with newly developed tools in that project. So now we have kind of a contract how to integrate semantically tools into our architecture. So I think it would be interesting to hook that up with other architectures or systems in that spirit of, let's say, have an analysis toolbox or the app store. So we might provide some apps to the analytics app store from that project.
That would be the role of the 16th standard, is it?
Yeah, well, this is a little bit by convenience. So this format pre-existed from a European Network of Excellence that was a product of several research groups, and it is not very complicated. So I think some XML transformation to other formats are not that critical if it's event-based. There could be some interaction with weblogs. We currently don't use weblogs, so probably we would have the force abstraction layer in his pictures, because we have kind of an action-based log file format. I think it's more allowing interoperation on the data formats. We are not claiming to have the 16th standard.
Okay, I don't know if you want to follow up, but Ulrich has a... You'll talk with him longer afterwards, okay. Yeah, because you're suggesting use weblogs as a common level, but also, well, let me send this down here.
Thank you. Yeah, very interesting, Andy. My question doesn't go to the implementation level, it's more the contextualization. I mean, I hope I will be constructive, but let me start with the following challenge. You may hear that what you're doing there, that's not really learning analytics, that is intelligently supported CSCL, which is an idea that was around maybe 15 years ago already, and there are examples also. But I would turn that constructively. I think we need to build our kind of evolution lines also, and I think here is one point and that is something that I would like to check with you. For instance, open learner modeling for collaborative learning. This is something that, in my understanding, connects very well into what you're doing here. Mm-hmm. And for me, it's also something that connects very well into LAK in general. Mm-hmm. So would you follow that, or?
I would follow you. I think I buy that with the intelligently supported CSCL. What is different here is that we really have a very heterogeneous environment with specialized learning tools. So about the open learner modeling, it is implicit now in this reflection tool, so the student will get feedback about what the system collected about him. It's not an open learner model that you currently can manipulate or correct, so we didn't have that in mind up to now. Might be interesting too. Yeah. But still, it's not very, let's say, skill-based oriented or something, or what we had in the first keynote. It's relatively unbiased still. If you start or finish an activity, if you created an artifact, so it rather supports here reflection on the student side. So we still think that the loop inside the head is more important than the loop in the system.
Okay, we're going to, while she's setting up, just a quick question along the lines of building on prior work. To what extent are you using, building on the plan recognition literature?
Pardon me?
Plan recognition?
Planning recognition, yeah, maybe there the terms overlap. So we don't use regular techniques of planning recognition. We call these graphical models plans for these.
Yeah, go ahead and switch.
Yeah, for these learning processes, and we rather currently use workflow engineering techniques for analysis. Mm-hmm. So we have some, let's say, structural properties that a good plan should fulfill, and rather use that.
Okay, well, okay. Thank you.
So thank you again.